Morning, everybody. It's great to be here again, 2 years in a row. Thank you, Hacking Paris, for bringing me here. My name is Matthias Katz. I'm from Argentina. And this year, I wanted to bring you a project that we worked with a couple of friends from work about open source intelligence. Who here knows what open source intelligence is? OK. Couple of friends at work, with Christian and Pepe, we decided to we like to debunk things. We like to break things that appear as elite or exclusive on the internet, and we try to break it. So this time we went not on this type of open source intelligence, but we went on this type of open source intelligence. This is Mention, the biggest and most famous service that gathers information from social networks, and then it brings you the information that you request when you purchase the service. If you are a company like Coca-Cola and you don't know what people are saying about Coca-Cola, you can hire them, you can pay their fee, and they will bring you a lot of information regarding what is mentioned about Coca-Cola in social networks. And for that service, they charge you a lot of money. They can charge you up to $800 a month for how many mentions? 30 alerts and 500,000 mentions a month. And then we have a lot of other services that provide the same thing. According to their level of famousness, they charge you less or more, but they do charge you a lot. So in this talk, I'm going to show you exactly how they do their work. I'm not going to reinvent the wheel. I'm not trying to do that. I'm not saying I've invented anything. This is normal. This is common. This is known. I'm just going to give you away the wheel for free. This is not a software that we sell. This is not something that I make profit out of. This is something we did for fun. And at the end of this talk, you're going to be able to replicate all this and create your own super scraping open source intelligence tool with only $0 to invest. So there's only 3 steps needed to get a cool open source. Can I get a video here? Can I get the video here? Thank you. There's only 3 things that you need to create your own open source intelligence scrapping tool. You need to search for some information. What you're going to sell, what you're going to use is the actual information. So you need to find a proper way that is comfortable, that is easy, that is sensible, that it's meaningful, that you get the information that you're going to offer to your clients or whoever. So you need to find that information somewhere. Then you have to put it somewhere. You have to present it in a way that it's important to the client, that it's meaningful, that they can interact with, that they can make a consult, that they can do a lot of input and output and have the information mean anything. It's not just a JSON that broadcasts information. It has to do something a lot more better. And finally, the most important part that you have to have on your tool is that you have to give the information some value. If you don't give the information value, then you're just a broadcasting service. You're nothing better than Twitter itself or a newspaper or a blogger or whatever. You have to give something extra to the client that says, here, this information is yours. This is what you paid for. This is the important part. This is the extra service that I'm offering you to give your information something that it's worth it to you. So I'm going to go in advance in all 3 items. So we did it not for profit, because again, this is free and you're going to be able to replicate and create your own tools after this talk. So profit is not the end point. We did it for fun, of course. We needed to kill some time, so we dedicated a couple of hours to this project. And there's a lot of smoke and mirrors out there for a lot of services that sell this, but they don't offer anything important or anything significant of difference. So it's not that much big of a deal. And of course, the requirements for this are very simple. You just need a dedicated server. We use a VPS for this, which costs us about $3 or $4 a month. That's the only investment we had to do. Then we had to get some APIs and some open authentication keys, which were all free, of course. And it took us about, all 3 of us, we spent about a week of us in shared time. We sat down, we researched what we could do, we learned the code, we learned how to interact, We made some mistakes. We corrected those mistakes. And at the end of the week, we have a fully working product, which wasn't 100% pretty, maybe. You're going to see in a bit, but it's working. So the other part is just making it beauty. It's not that important. But the working project was only after a week. And we only had to make 1 or 2 calls to the Python gods, which helped us a little bit. But the best part of all is that we were able to maintain it 100% free and 100% anonymous. You don't have to give any credentials to be able to access all these services, and you don't have to pay anything. The only thing we had to pay for is the dedicated server, because we didn't want to have it in-house. If you have a server in your company, your house, whatever, you don't even have to spend those $3 a month. So the first part is search for information. We need to find information somewhere, which is, by definition, the main premise of open source intelligence. You have to access public services to get the information you need to provide your input. So we thought about social networks, search engine, and we took a trip to Mordor to see what we can find, and we couldn't find anything better. So we chose social networks. For this demo, I'm going to show you Twitter. You can use Twitter, Facebook, you can use a lot of different social networks and different engines that gather information from search engines and translate that into viewable data. Or you can use a few scraping tools for Google or Yahoo or Bing that can give you JSON information for any kind of query that you can request. So we focus on Twitter because it's a little bit more fun to show you Twitter other than Google or whatever, because it's more dynamic. You're going to see in a minute. Interaction with Twitter was really easy. Twitter has a very easy API. You only have to make a couple of calls to make it work. It has a very bad performance. Twitter tends to fall when you kick it a little bit. If you push it a little bit, and if you ask a little bit more information, it just drops, the whole service drops, or you get kicked out of the API. So you have to treat it nicely. We did 5 requests per second, and we were OK with that. If you want more, then you have to switch to a better service, of course. But if you don't request too many crazy things to Twitter, it'll respond perfectly fine. You're going to see in a minute. It's very good. This is Python. You only need a couple of things. These are the keys, the OAuth and the Twitter stream. You have to import into your code. And then you want to set up a block with the object OpenAuth with the token secret, the consumer key, and the secret, which is all given to you when you create an account in Twitter Development Service, which is free, and you can do it with a Gmail account 100% anonymously. So you can create that here. This is my user. When I sign up to the developer team, I get the OpenAuth tool, and then I get the consumer key, the consumer secret. Of course, I should be showing you this because it's a secret, but I'm going to change it as soon as my talk finishes. This is a secret, and then you have the access token and the secret for the access token. So with this information, which creates the authentication for the stream, you can create your own. You can create your own object, OpenAuth, and then you just have to hit the Twitter stream, authenticating with the bot, and then you just you search for stream.twitter.com. And then after that, you just created an object that authenticates to the developer API, and then access the live stream of raw Twitter information. Then you just have to type a superword Coca-Cola, and then, while true, if for each tweet that you get in the stream, if in English, if the superword is in the tweet, then print the text. It's as simple as that. You have to set up. You can set up and filter the language. If you want specific tweets in specific language, you can filter that here. And then after that, you just filter like you would filter any kind of text in a Python script. So this is very simple. This is the OpenAuth tool. And then I'm going to create, go back. I'm going to create a request via GET to the API.twitter.com. and then I'm going to search for the word Coca-Cola. When I get this, the signature, it creates, this is a 5-minute window cookie that Twitter creates for testing purposes. Then it creates a curl line when you have all the information to the consult. So you can see I have the consumer key there in the signature, and then I have here, where is it? Okay. There you go. The timestamp for the OAuth. After this, I'm going to communicate with Twitter, and what I get is a JSON. Just give me a sec. This right here. Just copy this. This right here is one tweet. So I have the URL, the object, then the expanded URL, the display URL, the description, the date, how many the favorite count it has, the timing in which it was done, the background image of the user which posted the tweet, all the information regarding the user, all the information regarding the tweet, the information if there's an image or a link, and all the information regarding the metadata of the tweet. All that in one JSON object. So this is as simple as that. If you use it directly on your code this way, you don't have that 5-minute window. You can use it forever. By using the same information you got from the website, from the OpenAuth, from the developer website, you can use it forever, and you have it on your own Python script or whatever script you use, and then you can get information forever, a while true, and that's it. So this is getting the information. It's as simple as that. A few other social networks are a little bit more complicated. Facebook has an issue with getting the APIs, but you can bypass that and get the information, get the access. But everything sums up to this. Setting the object, authenticating to the object, using the object to get the stream, filtering the language, searching for your word on that stream, and that's it. Just one thing to clarify. This search, the thing we saw here, this is one tweet regarding a Twitter stream of my keyword. I've already filtered the keyword before getting the stream, so Twitter is doing the filtering for me. And it's not looking for hashtags or mentions. It's looking for plain words, so you don't have to search for a specific hashtag. You don't have to. You can search for only a word. So the second part is to put it somewhere. I have a JSON, which is ugly. It took me 1 minute to show it to you guys. Copying it, putting it on a text editor, lowering the font, selecting, trying to read through the whole text. It's not pretty. So you have to put it somewhere that it's pretty, that it's going to be able to show to the customer, and that they're going to be able to read it in a fun, easy way, and that they're going to be able to interact with it. So you can use online maps provider, you can use a MySQL database, or you can use an Excel sheet. Please don't call me if you use an Excel sheet. We chose Google. Why did we choose Google? Of course, Google has a really, really, really easy API. Instantiating the object, calling the object, creating the markers, creating all the interaction markers for Google Maps, it's very easy. It has a great performance, of course, it's Google. It cries a little bit when you push it, when you try to force it, it cries. Of course, it's Google. Anyone that's done a pen test knows that about Google, as soon as you've done 5 or 10 searches, it starts with the CAPTCHA. Here, it doesn't start with the CAPTCHA. It doesn't do anything. If you start pushing it, it just stops. So for the free service that you can get the keys anonymously, of course, too, if you set up to about 5 impressions per second and up to 50 geocoding per minute. Geocoding is when you type a city and then you get the information about the city and including the latitude and longitude. If you do 5 searches per second and less than 50 geocoding per minute, you're going to be OK with the free version. And of course, Google will just give you the data. To create a map, you just have to call the API inside a script in a JavaScript. You have to call that, and then you have to create a geocoder here, which is, hold on. You instantiate the map here, and then on the body, you create a new object map, and then you create a new Google Maps, and then you set up the host, which is going to be this div object. So we have to put this with the map options. Map options are going to be here for the map options. Zoom number 2, which is from the closest to the biggest. Number 2 is the second widest one. And then you create the center. Where do you want your map to begin? Latitude and longitude. And what kind of map do you want? You have satellite, you have terrain, you have the hybrid. They have a lot of more options, but this is the basic stuff to create your own map. If you take a screenshot of this and then you put it on your code, you have a Google map, a fully interactive Google map. After this, we need to create the geocoder. The geocoder is going to work for us to be able to create pinpoint cities, countries, whatever, and then inserting that into our map and making them work in some way. So after we created our map and we create the geocoder, we just have to create our very simple code that creates the geocoding engine itself. So you create the variable address, and then you send the code, the information in that variable. So if the status is OK, I mean, if the geocoder was able to find that city, if you let your cat on your keyboard and starts typing a lot of things, Google's it's not going to find it. But if you type a correct city or a country or a pizza place, whatever, and Google finds it, it's going to give you a status OK. So when it gives you a status OK, it's going to create the variable latitude, which creates the geometry, the latitude from the geometry of the place. That's all information that's going to be given to you by Google. The same with longitude, and then you create the final variable lat long, which is created by the combination of the latitude and longitude from before. After that, you just have to create a marker. A marker is the visible red dot that you see on the maps. So you create a marker with the information from the marker here, a map and the position. And that's it. After that, you have this. Whoops, not that. Oops. You have here this very nice geocoding service. This is a fully functioning Google map. And I can type press, and then it does this. That's it. This is the basic stuff. We created the map, and we were able to create geocoding service and the marking pinpointing that. So it moves the map to the city, it centers it, it puts the zoom enough so you can see it, and then it creates the marker. And then you can interact with the marker any kind of one. I mean, you want to make the marker clickable, to interact in some way, whatever, you can do it. Of course, you can put it to keep pointing things without deleting the one before, or you can just create a new search. The FAQ in Google is very helpful. It has a lot of information. If you can just spend a couple of hours reading it, it's very helpful. Just so you know, what is going on inside is here. This is the URL for the API. And the JSON, now we're going to find the raw information that Google is managing before pointing that graphically into a map. If I put Paris here, it's going to give us all the information that Google Maps knows about Paris. So, Paris, France, latitude, longitude, southwest. For the northeast, for the southwest, and the average location. The approximate location, which is going to create the bounds for what Google knows, what is the beginning and what is the end of Paris. This is what Google knows. So you know if you've gone too far away from Paris, Google will know according to the latitude and longitude of the object that you're marking. If you click on any other part of the map, you can know if it's Paris or not because of the bounds that Google is creating by the southwest and the northeast and the center. And then there's a lot of other information regarding Paris, Texas, USA, of course. And then it has the information sorted by likelihood. There's a more likelihood that if you type Paris in Google Maps, it's going to try to find here than Paris, Texas. And that's according to feedback from users. If Google knows that a lot of users have searched for Paris, and the map has taken them to Texas, and then they have strolled to Paris, or they have put on the map Paris, France, then Google learns from that and changes. If I put here Paris, we have here, but if I put Paris, comma, USA, I get Texas. So that's what Google is doing right now. You can do that on your own engine. The more information you give the geocoding, the more integration you're going to have with your code. So now we have to give it some kind of value. This is the most important part. This is the part that we took the most effort in, the part that we're mostly proud of. Because up until now, we just used a service that is available online, and then we just translated that into our code. But now we're going into the fun part. When you give it some value, you do have to match the specific keyword. And we chose to do syntactic analysis for it because it's what we said it was going to give us the most kind of information from a computer from human input. So, of course, you're not going to do manual checks when you have 500,000 mentions. But if you have a couple of mentions manually and you're doing if you're not doing a live report, and if you don't have that many impressions, I can recommend you doing manual checks. But if you're not going to have that, if you're doing a live service like most do, I certainly don't recommend manual checks. I prefer syntactic analysis. So we chose the Python NLTK library. Who here knows about the Python NLTK? 3 hands. Awesome. NLTK is a library from natural language toolkit that was created for Python, the older version, and just jumped to the new ones. It's a library that has a lot of information about syntactic analysis. It has information in multiple languages, and it can detect the different parts of any kind of sentence, and then it can create arrays of information regarding how many words are there in the sentence and the weight of that. I'm going to talk about that in a minute. It has a very easy implementation. I'm going to show you right now how to do it, how to implement it. It has a learning curve. The library has to learn. If you set the library to work right now, and you want to have viable and useful information, you're not gonna have, because it has to learn. So manual input is gonna help for the first, say, month or so, month and a half. If you have the information, you can print all the results from the tool, and then you should do manual checks to see this is a false positive, this is a false negative, this is a true positive, etc., 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 to make the tool learn. It has a long but very strong curve, because once it learns, it can't be stopped. It's very intelligent, very, very accurate engine. And it has a very, very good performance. It can check thousands of sentences in a couple of seconds with any average computer. Doesn't require too many hardware resources. What it does, it creates what we call symbolic and statistical analysis. What we do here, what the library is doing here, it's creating an array of interpretation of sentences. It's not actual AI. That's why I put all the, it's not actual AI. It's not intelligence. It's hard work and linear interpretation of data. That's it. But it's doing it so good that you think it's kind of intelligence, but it's not. However, what it's doing is checking all the time for appearances of different kinds of information, different kinds of words inside the sentence. If I say, my house is beautiful, I have an object, I have a noun, I have an adjective, I have everything. And I'm completely on track. But if I say, my house is beautiful, but I don't like it, would you say that it's a positive or a negative comment? I'm asking, please. My house is beautiful, but I don't like it. Is it a positive or a negative comment? Negative. I have one negative. Only one negative? Two negatives. Okay, three negatives. The thing is that the person that is saying that is saying, I don't like it. But it's admitting, objectively admitting that the house is beautiful. Maybe they don't like it because it's far away from work. Maybe they don't like it because the walls are blue and they like red. But they're saying that they don't like it. And that is very strong, in the sentence. So you, me, whoever, a person, can identify that part of the sentence and say that the I don't like it is much more important than the is beautiful. So that is what we are trying to do with NLTK. We need to make it learn that. So it, before NLTK does it, it has to fake it. You know the phrase, fake it until you make it? So what it does here, it separates the sentence into noun, conjugation, noun, adjective, and all that. All these you know, of course, from school. NLTK does this, and it creates an array of information, separating the phrase into the different parts and assigning each of them a different kind of weight. So according to that category and the weight for that category, specific category, is going to create a point system for each word inside that category. So if I have two positive adjectives and one negative adjective, it's going to assume that you're talking about something and your overall opinion on that is a good thing. So if I say my house is beautiful and clean, but it's small, do you think that's a positive or a negative comment? For me, it's a positive comment. It's only, okay, I don't have enough money to pay for a bigger house, but my house is beautiful, it's very clean, blah, blah, blah. Overall, it's a positive comment. Even though it's a small house, I still like it. I still think it's okay. I am still happy with my house. So that's what NLTK does. How many adjectives do we have? We have three. We have small, we have beautiful, and clean. We have two positives, one negative. So overall, it's a positive comment. That's what NLTK is doing right now to fake that kind of intelligence. To install NLTK, it's very easy. You just go pip install NLTK. After that, you go to Python, and then you do an import NLTK, and then NLTK download. And after that, you just go grab a beer or something, because you're going to try to download 2 gigabytes of information. Inside that 2 gigabytes of information has the knowledge base for about 25 languages to do the AI. So you can do this in about 25 different languages, which are all preset with NLTK. You can use whatever language you want, and it's going to be ready to work with it. Then you have to say to NLTK what language you're using when you're giving it the data, and that's it. Then we have to create the tokenizer. The tokenizer is the sub-object of NLTK that creates the array with each of the grammatical divisions of the string that you sent it. So when you send to the tokenizer, hey, my house is beautiful and clean, but it's small, the tokenizer is going to do that subdivision of the array, creation of the array inside the sentence. You have to do this. You have to do this to make it work perfectly fine. You create this tokenizer, you import the tokenizer, and then you send the sentence. Atlantic is awesome. And then you send the tokenized sentence, and then it creates Atlantic and it's awesome. And that's it. Now I realize that I opened the wrong PDF. It should say Hack in Paris. I'm sorry. It's Saskia's fault because she told me she was going to take 10 minutes. So it's your fault. So we create the array, and then it separates the sentence into the subject and the rest of the talk, and then the rest of the sentence. And then it goes all times recursively until it separates the sentence into all of its parts. Then we run the frequency. When I check frequency, of course, I check how many mentions of a specific word are inside each of the category. And after that, it starts to give value to that word according to weight. But the weight, it doesn't have anything to do with the kind of word it is. It depends on, it doesn't depend on how many times you use it. It depends on what type of word you're using. So each word has different weight according to how much means that word to the sentence. So if I'm using the yes, no, it's different than if I'm using the but, to, for, it's different. So the frequency is going to do that. It's going to separate the non-important words from the important words, and then according to the frequency appear on the sentence, it's going to give them some value according to their weight. So we create the features for the string, and then we just run the training set from the string itself. What it's going to do here, after you've separated that, it's going to create an array with the weight and the value of each of the words inside that. And then it's just a mathematical calculation. So we classify the tweet. Then we return the classification from the tokenizer. We have to go through the tokenizer first. So we have the string. The string is my house is beautiful and clean, but small. Then we run it through the tokenizer, and then we do the classifying. And it's going to give you a value between 100 and 0 to how positive it is. If it's a 0, it's a complete negative word and then sentence. And then starting from 0 to 100, it's going to go to 100% positive. So that's it. So this is very easy. Hold on. I have to log on to my server. I'm going to do this is what I'm doing. I'm creating the extract. This is in Spanish, but don't worry about it. This extracts words from tweets. And then we create words sentiment in each tweet. Then we create the characteristic with the frequency list. After that, we create the word list with the keys. We create our own word list with the keys that is run from the frequency list. Then we run the classifier from the tokenized from the tweet upstairs. And then we use the positive and the negative seeds that we pre-created for the learning curve. I'm going to show you this in a minute. We have the positive and negative, and it's going to run the negative tweets through the positive, and if it shows there from the learning curve, if the feedback from our positive list appears on that string, it's going to add 1 point. And if it's not, it's going to subtract 1 point. That's what it's doing. So right now, I have positive.txt and a lot of positive sentences. You are my perfect match. You are priceless. This is too cheesy. And all that. These are all positive phrases. So from here, NLTK is taking what is a positive sentence, what are the most likely words to appear in a positive sentence, etc., etc., etc. The bigger the seed, the better the result with NLTK. This is the learning curve that I was talking about. You can set up NLTK to learn from itself. After it detects a positive result, it can add that positive results to their own seed. But you have to be careful, because that's a machine learning from a machine, so it can go very badly. But if you pay attention, and each time you audit the tool, and then you cross-match and see if that's a real positive or a false positive, then you can create a very strong knowledge base. After 2 months or so, with a couple of inputs from you people, it's going to be awesome. If I do cat negative, yeah, I had to babysit. We thought that was a negative mention. I got bored. I dislike. I don't like. We are more friend material. And look at that. Can we talk? You can laugh, but it's awesome because it's truly, it works. Who here can hear the phrase, can we talk, and not be afraid? By a partner, girlfriend, boyfriend, boss, whatever. So it's truly negative. So if we were trying to fake intelligence, what better way than to include sarcasm and all that is not implied in the sentence, because can we talk doesn't have any negative word. It doesn't have an insult, doesn't have the word no or any derivation of the word no. It doesn't have any negative words itself, but you know that it's a bad phrase. And that is what we do when we think and we interpret the phrase. And that's what we are trying to teach NLTK. So later, if NLTK reads a tweet that says, hey, I need to talk to you, it's going to interpret that it's trying to say the same thing in a different way, and it's going to pinpoint it as a negative tweet. That's what we're trying to do here. So that's why it doesn't have all the negative basic stuff. It has different kind of things too. So if we run Python to the phrase, I like Coca-Cola, it's going to say that it's a positive comment. But if I say, I dislike Coca-Cola, it says positive too. Why? I don't know. I have no freaking clue. It's supposed to say negative. You see, it has false positives. But if I say, even though, check it out, dislike is in the negative seed. But even though I use dislike in the negative seed, some way, for some reason, it's thinking it's a positive comment, even though it has the word dislike in the negative seed. So it's not just a string match. It's actually doing some interpretation, which can fail, of course. What if I put, I don't like Coca-Cola? It's a negative comment. Okay. I don't like Coca-Cola, but it is very good. Still negative. Okay. What about, I like Coca-Cola, but it's shit. Negative. You see? I'm sorry for the insult, but it has to be done for the demo. The negative comment is so strong that even though I'm saying I like Coca-Cola, it's not taking it as a positive comment. That is the strength of this. It's not just checking for words, and if there's an if, oh, if it appears the word like, then it's a positive comment. No. It's a lot more than that. It's doing a lot more interpretation of the sentence. So, what do we do? What did we do on this? How do we complement all things? We have a live Twitter stream search engine that filters anything we want. We have a Google Map interactive object that we can put all the information we want and create geocoding map markers and all that. And then we have a tool that creates syntactic analysis to detect fake intelligence and detect whether or not this is a negative or a positive comment. So what we created is this. This is a live, this is the final product. This is a live Google map that is searching for a specific word live through Twitter and then doing the syntactic analysis of the tweet and then posting it on the map with a red or a green dot according to whether or not this is a positive or a negative comment. I started this search right before my talk started. Now we have 1,008 results. And this is the result for the word Brexit. Yes, this is Brexit. So if I click on some tweet, I wonder what today's shock news will be. It seems something every day. I can't believe it's only been 1 week since the Brexit vote. Nice. One from Ireland. Oh, this is in French. Sorry. Interestingly, vote Leave dominated Twitter Brexit debate, as it did in England. On social media, blah, 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 blah. We have a couple of tweets that are not significant, and then we have a couple of tweets that are going to be significant. I'd rather focus on the negative ones. These are the most fun. Constitutional expert on why Brexit should not happen. That's a negative tweet for NLTK. I'm not talking about politics. Just before that, last time I tried this, I tried it with Donald Trump, and I put it on the US. And as you saw the US map, you can see clearly the east half of the US was all green, and the west half of the US was all red, except for California. So it was all green, all red, and California green here. It was awesome. So if we zoom out here, and we try to see the rest of the world, look at that. This is what the world is commenting right now live on Twitter about Brexit. So you have, this is truly amazing. You can take account of about 5, 10%, 20, 15, 20% max of false positive or false negatives. But the overall opinion on the Brexit is pretty clear, which makes you wonder what you can do with all this information. Not about Brexit, this was just an example. What can you do with this information? What kind of searches can you try on this type of tool and then gather that useful information live? We are processing this about 7 seconds after the tweet has been done. If you put post tweet, 7 seconds later, I have it on my map, processed, and geocoded. So you can have live information about something more than just what people are saying or what are the newspapers saying. You can have real information, feedback for real people live. So this was very, very fun. So yes, that's it. Thank you very much.